Okay, this one says there exists a unique real value x. That's a nice thing they're telling me over here. Such that this thing satisfied that. All right, there's some x that satisfies it. It's unique, it's only one, right? Compute x. Let me go to the whiteboard and I'll talk about it. Oh, before I do that, again, I want to point out, I'm getting these questions from this Stanford math tournament. Again, it's an annual high school mathematics competition by Stanford University, basically run by a group of students, by the way. And it's there to promote interest and enthusiasm for mathematics among high school students. It provides challenging problems, by the way. Now, by the way, they are challenging. And I'm not saying this one in particular is challenging, but every problem they give you is interesting. I thought this is an interesting problem too, by the way. All right. Now, granted, some of the questions on the exam, I wonder, where they get these things from. But my suspicion is they're probably things they've seen before, and they thought they were interesting, and they're just going to rehash them. Now, by the way, there's a ton of interesting problems out there, but the more you do, the more apt you are the more capable you are in doing problems like this. Let's go to the whiteboard, and let's talk through it. All right. So the first thing I want to point out, and just looking at the problem, is I want to write it down, and they say x is a real number. So x is a real number. And then they go on to say that x plus the root of x squared is equal to 16. All right? They want me to compute the x. There's certainly many ways to do it. I mean, I'm not going to say one way is better than the other, but we're dealing with real values of x. So x is a real number. We know that much. And we know that the root of x is going to be a positive number. We know that. Principal root, by the way. So looking at it, I'm going to say x is going to be greater than or equal to 0. And I'm going to go on to say that x plus root x is greater than or equal to 0. So this makes it a little bit easier for me because then I'm looking at this. I can just put down x plus root x equals, it's a positive number. I'm going to use plus or minus. It's going to be equal to 4. I use square root rule, but I didn't say plus or minus. Then the question is, what do you do about that? What I would do is, what I've always done, is just isolate the radical. That's 4 minus x. And then what I do is I square both sides. I get x. Over here I get 16 minus 8x plus x squared. Well, it looks pretty simple. You get x squared minus 9x. Right? You take 1 from both sides, and then plus 16 is equal to 0. And I can write my x down now. And what's my x going to be? Well, 2, 9, plus or minus, this is where my trouble comes in, 81, and then minus 4 times 1 times 16, which is 64. Whoops, 81. This could be x equals 9 plus or minus. This is going to be 81 minus 64. That's 17. Well, I'm certainly getting real numbers. That's good news. My question is, I wonder, they said it's unique. It can't be both of those. So let's go back and think about it. Is it x equals 9 plus root 17 over 2, or is it this one? All right, I want to point out, looking at this one over here, the square root of 17 is certainly greater than 4, and 4 plus 9 is 13. So this one over here is going to be greater than the number 4. You may wonder why I'm concerned about that. The reason I'm concerned about this is over here. So this one's out of the question. Because if it's greater than 4, I'm saying the principal root would be negative. That's not happening. Let's do this one over here. What do you get over here? Well, if I look at this thing, I want to make sure I'm doing this right, by the way. 9 minus root of 17. Well, I'm going to say roughly around 4. So 5 has 2.5. And that certainly makes sense to me. So this is the answer. And we are done. Thank you.